the bank accounts, for instance, from my grandma, or the phony tokens. And in addition, these credentials can also be used to flood and trace the fisher. I will show this later on. But of course, this postulates that the banks or the target of the phishing campaign has something, a feature in order to prevent automatic validation. For instance, a capture. So it's not possible for the fisher anymore to make the validation of his phished accounts automatic. So therefore, for this purpose, we invented a small framework. We call it FishPhucker Framework. The framework consists of three main components: the pre-analysis system, the FishPhucker mainframe cluster, and the FishPhucker Firefox extensions in the wild. So we will now have a deeper look at these three components. First of all, the pre-analysis system has the purpose aggregating, analyzing, and profiling. This means we have to get, or we have to collect a lot of current phishing pages, then we have to analyze them, and then we create specific phony tokens for the phishing campaigns. The mainframe cluster contains the phony token database and also has the logic for the phony token distribution. This means it sends out the phony tokens to its clients. And the Firefox extension is the executing unit. It's just I would say a slave. So the pre-analysis system is currently pretty, primitive. It's just a bunch of badly written Python scripts, but I will show you later it works currently. So aggregation of phishing websites. In this case, we can leverage from already done or already established projects like the fishtank.com project. I think some of you will know this project. It's a big database where they collect in a very good way phishing websites. So we get this data, for instance, from FishTank, the phishing websites. After that, we will call the phishing websites by ourselves, and we will analyze them. We will check what are the additional data we have to request, like it's CSS files, JS files, images, etc. And what are the form fields? How do these form fields look like where the credentials are submitted? And after that, we will create suitable phony tokens for this phishing campaign. So again, small video. So we give it the domain name of the phishing website. And as we can see here, now the first thing the script does is searching for additional files to request. This means it knows, okay, I requested the index.php. Now I have to request the CSS file and the 3 images. After that, we are searching for the form structures where the credentials are submitted. So we find an action tag. Okay, the data goes to verified.php. The form method is get, and we have several input types. Subsequently, we are creating the phony tokens, and I will show you. That's a pretty primitive way, but it's the best way to show you how this works. So we store them in a database. This is the phony token database. These are the fake credentials. So the set of phony token data, and these are we call this pre-URI data. So the additional files which have to be requested. All right. So the second component, the FishPhucker mainframe, it's the central unit for distributing phony tokens. This means, as I already said, it contains the phony token database, and it's currently only a web server with a MySQL backend. And if a client connects to these servers, it just says, okay, I will give you this and that phony token. And it's important to know that the server contains all the logic. This means that the client does not have any logic. It just says, okay, give me some data and I will do the work for you. And we have solved this problem of distribution by implementing all the stuff in an XML structure. One of the main fields are, for instance, in the next update field, it's the time to wait until the next phony token is requested. This means the extension will request the phony token, does attack the phishing website. After that, it has to wait a given amount of time, and then it will request the next phony token. For this purpose, or for this request of a phony token, it needs a ticket, a valid ticket. The user agent, yes, we have a problem that currently this proof of concept is only available for Firefox. So it's a little bit odd if we just flood all the phishing web pages with a Firefox or a Mozilla Firefox user agent. So we said, okay, let's create a small database of user agent, and we randomly choose user agents which are sent to the extensions, and these extensions now pretend to be, for instance, Internet Explorer or Safari or something like this. The pre-URI fields, these, as I already said, these are the additional files which have to be downloaded, because it's quite obvious why we do this. As I have already shown, in the server logs of the web server, you first see the request for the index PHP and then the additional files. So if we try to simulate the behavior of the browser, we have to do it the same way. The extension has to first to request the index PHP and then the additional files, and then have to wait a given amount of time. This is called, in this case, it's the delay field, because we have to behave like a human, and a human needs time for filling in the form fields with this private credentials. So we shouldn't request the index files and all the additional files, and after that immediately send the phony token to the phishing server. We have to completely simulate the way a phishing victim would work. So therefore, delay is the human response time. So the third main component is the Firefox extension. Currently, it's written in JavaScript. We also use some XUL and cascading style sheets. It's compatible with the current Firefox, and it automatically requests phony tokens from the servers. As we can see later on, you just have to install this extension, and the rest of it is automatically done by the extension. There's no user interaction needed. And if the extension works, it perfectly simulates proper phishing victims. It requests all resources, as I already said. This is very important. And it considers the human response time. So for the connection between the clients and the server, we have established our own protocol which gives the complete power about the distribution of the phony tokens to the server. It's very important, as we can see later, that the